So for the AP Calculus BC free response question number 1 from 2018, okay, it deals with a scenario where people are getting in line or entering in line for an escalator, and they're also getting off the escalator, right? So this is an in and an out type problem. It's a rate and accumulation problem, okay? So we're adding to the amount of people with R of t, right? Because that is a rate. Okay, so it's measured in people per second. Okay, and then it also tells you that they're getting people get on the escalator, and as people get on the escalator, they exit the line at a constant rate of 0.7 person per second. So this is a derivative, and also this is a derivative because they're both rates. Okay, and we also know that we started with 20 people in line at the start at t equals 0, okay? So question A, how many people enter the line for the escalator during the time intervals 0 less than or equal to t less than or equal to 300? So this one, we're only considering the people that are getting in line, okay? The people that are entering the line, okay? So R of t is the rate at which they're entering the line, right? So we have to integrate that from 0 to 300. So we need to integrate from 0 to 300 of R of t dt. So let's do that. This is a graphing calculator problem, so we can use that, okay? All right, and I'll go to my paper and we'll work that out. Okay, so I'm on my paper, and what we're gonna do is we wanna integrate from 0 to 300 R of t dt, because that's the rate at which they're entering the line for the escalator, okay? So we'll put this into our calculator and we'll figure out what this number is, okay? So I'm gonna go to my graphing calculator now and we'll put this. So something I just realized I neglected to tell you guys is that R of t is a piecewise function, right? So from 0 less than or equal to t less than or equal to 300, it's this function 44 times all of this, okay? And then for t greater than 300, it's 0. So what does that mean? That means no people, it's 0 people per hour, or not per hour, per second after 300 are getting in line for the escalator, okay? So we're integrating from 0 to 300, so we only want to integrate this piece of the function, okay? This piece, okay? Not the 0 piece, all right? Okay, so let me go back to my graphing calculator and now we'll do that. Okay, so from our calculator, okay, we want to put in the function for y, okay, and make sure, because you never know when you're going to have trig functions, always just double check, are you in radians, okay? All right, so now we want to go y equals, and we want to put in, I would always put these in for your functions if they give it to you, into y1, all right? So parenthesis, and then we have a fraction inside the parenthesis, and then x over 100, because we can't put t. Okay, and then come out of the denominator, 100. And then come out of the denominator and put a parenthesis, and then we want to cube this. And then come out of the exponent, and then open another parenthesis, and then 1 minus, and then we need another fraction bar. Okay, and it's x over 300 instead of t over 300. Then I'm going to go to the right of that and close the parenthesis and then raise that to the 7th. And I think it's always a good idea to go back and just make sure you type this in right. So I'm double checking right now just to make sure, because it'd be awful if you knew what to do and then you just accidentally type something in wrong. Okay. All right. So I'm going to go back to my home screen because I've checked to make sure I typed it in right. Okay. And we want to integrate from 0 to 300. So that would be function integrate. So alpha, window, and then number 4 for function integrate. And then we're going to go from 0 to 300. And then our R of t was y1, or at least that piece of R of t. So alpha, trace, and then number 1. And then x. And then press enter. Okay, so 270. So I'm going to go back and record this on my paper. Okay? All right, so this is 270 people. And that's how many people entered the line between 0 and 300 seconds. Okay? All right. So then let's go to part B. Let's go ahead. I take that back. Let's go ahead and let's write a statement for this. Okay? All right. 270 people 270 people entered the line to the escalator during the time interval 0 less than or equal to t less than or equal to 300. So you want to say what you got and then the time interval. Okay. All right. So now let's go to B. Okay. So for part B, they're asking for they're telling that there's always people in line for the escalator. Okay, between 0 and less than or equal to t and less than or equal to 300, and then how many people are in line. Okay, that's not how many people have entered the line, because that's different. That was part A. Okay, how many people are in line. Okay, so we have to initially start with how many people were in line, and then figure out how many people were added to the line, and then also how many people were removed. So it's like three things, right? So we started with 20 people. Okay, we know we have a rate at which they are entering. So if we integrate that, that's going to get the number of people that entered the line, right? And then we can also need to remove how many people exited the line, okay, or exited the escalator, which in essence be exiting the line, okay? All right, so here we go. Let's do part B. For part B, we know we started initially with 20 people, okay, and then we added, okay, and what we added was we added the people from 0 to 300. So 0 to 300 r of t dt. But now, okay, so that's how many people between 0 and 300 people, 0 and 300 seconds, how many people have been in line, okay? But some of those people have been removed. So we need to remove the integral from 0 to 300, and we need to integrate from 0 to 300 the rate at which they're being removed. And it said it's a constant rate of 0.7 person per second, okay? So 0.7 dt, okay? Now, this one we already know, right? It's 270. We just figured it out up here. So this is, we don't have to do that again, okay? So this would be 20 plus, okay, 270 minus, okay, now this is a really easy integral to do, because this would be 0.7 t, right, when we integrate it. And then we put 300 minus 0. Now this is a lesson I taught you guys, okay? When you integrate a constant, you can just take the constant times the upper limit minus the constant times the lower limit, right? So it'd be 0.7 times 300 minus 0.7 times 0. And we're going to subtract, we're going to have to subtract that quantity here, okay? So this would equal, this would be 290 minus, okay, this would be 210, okay? And that would give you 80 people. Okay, so what does this mean? They're asking you how many people are in line at t equals 300. So we would say at t equals 300 seconds, 80 people are in line for the escalator. Period. Okay, and that's the answer to part B, guys. So for part C, for t greater than 300, what is the first time t that there are no people in line for the escalator, okay? So if we consider part B, where how many people are in line at t equals 300, right? After t is equal to 300, the rate at which they're entering the line is 0. So nobody's adding to this line, okay? So all that's going to happen is we're going to start at 300, And we already know how many people are in line at that point, okay? And then we just need to remove and see when we would have there be no people in that line, which means 0 people, right? Okay, so let's go to part C and I'll work this out with you. Okay, so for part C, we know at the end of 300 seconds that there are 80 people in line, okay? And at the end, from 300 seconds on, no one's entering the line, okay? So we're not going to add to this at all, but we are still removing, right? Because we're removing at a constant rate of 0.7 person per second, right? So then what we have to do is take this 80 and minus the integral from 300 to t of 0.7 dt, okay? So we want to know after 300 seconds, we have 80 people, or at exactly 300 seconds, we have 80 people. And then from there on, we're removing them, right? And we want to know when this becomes 0, because then that would mean there's nobody in line. We've removed the same amount as what we had at 80, okay? All right, so we need to integrate this and then solve it for t, okay? So this would be 80 minus, and it'd be 0.7. And you guys, you know what? I should put dx right here, not dt, for the dummy variable. Let me fix that. If you put t, they're not going to mark off, okay? Because they understand that, okay? So 0.7x, okay? And we're going to evaluate that from 300 to t, and we want to know when that's going to equal 0. So this would be 80 minus, and it would be 0.7t minus 0.7 times 300. We want to know when that equals 0, okay? So this would be 80 minus 0.7t, and then this would actually be adding 0.7 times 300, right? And that'd be 210. So plus 210 equals 0, okay? So this would be 290. So we have negative 0.7t plus 290 is equal to 0. That'd be negative 0.7t is equal to negative 290. And then t be negative 290 divided by negative 0.7. And that would give you, and I'm not going to put that in my calculator because it's just a calculation. And it would be 414.286 seconds, okay? So we would say at t equals, or approximately 414.286 seconds, there will be no one in line for the escalator. Okay? And that's the answer to part C. Okay? Okay, I'm going to let A of t equal the amount of people waiting in line for the escalator. Okay, so we're going to need to know, this is the function that we're trying to find the minimum of, okay? So the derivative of that, right, a prime of t, would equal, okay, and that's the rate at which this is changing, and it would be made up of the two rates, the incoming rate and the outgoing rate, okay? So those are r of t minus 0.7, okay? And what I want to know is find the critical number. So I want to know where this is 0, okay? So basically I want to know this, r of t minus 0.7 is equal to 0, okay? Or r of t is equal to 0.7. Okay, so we have R of t in our calculator, right? Because that was the rate that we took the integral of and we took the derivative of earlier. Okay, so I'm going to go back to our calculator and we need to solve this. Now, what is this going to give us? This is going to give us the critical numbers. Okay, and then we're going to check the critical numbers along with the endpoints and just see which one's going to give us the smallest for this A of t. Okay, all right. Okay, so I'm going to go to my calculator now. Okay, so if I go to y equals, okay, I know I have, this is R of t from 0 to 300. And that's all we're asking, right, is 0 to 300. Okay, so I want to go to my, I know this is going to be y1. I want y2 to be the 0.7. Now you could also subtract 0.7 and then y2 would be equal to 0 and you could solve that equation too. That would work also, okay? For my window, I know my min is 0 and my x max is going to be 300. Okay, and because what I put in is the time, okay, so 0 to 300 seconds, and then x scale is going to be 50, just because that'll give you several of these. Okay, y min to y max, I would go something like negative 300 to 300 possibly. Let me go negative. The rates are smaller than that. Sorry. So negative 10 to 10, because we have a rate of 0.7, right? So I'm thinking just go negative 10, 10. That's probably actually too much now that I think about it. Okay, let's go ahead and graph and take a look and see what this happens. Okay. All right. So what did they ask you? It happens here and here, right? Okay. So let's check this one. This is a critical value right here, and this is also a critical value. Okay, so I'm going to go trace, and I'm going to calculate the intersection, and I'm closer to this one, so I don't want to do that one yet. I want to do this one, and I'm going to want to store this. Okay, so I'm going to come over here, closer to this first one, and just press enter for the first curve, enter for the second curve, and then guess I'm close to the one I want to find. Press enter, and there it is, right? So we want to store this. I'm going to store this as A. Okay, and I'm going to record this number on the paper. Okay, all right, so I'll do that in just a minute. Okay, actually, you know what, I'll go to the paper right now. I'll stop this and we'll go and put it on the paper. So for this, we could say t is approximately 33.013, I think it was. Yes, 013. Okay, and then we got to find the other t value because there's two of them, right? Okay, now I'm going to go back to my calculator. I'm going to store this one. Okay, I'm going to store this one, and then I'm going to find this one and store that one. Okay. All right, so I'm going to stop. From the graph screen, what I'm going to do is I'm going to go to the home screen. So second quit, and we're going to take that x value and we want to store it as alpha a because we want to put the whole thing in. Okay, and there we have the whole decimal. Okay. All right, so now what I'm going to do is I'm going to go back to graph, and I'm going to press second, calc, and 5 again for intersect, and I'm going to come over here, and I'm going to pick up this critical value right here. Okay, enter, enter, enter. Okay, and then I'm going to store that one as B. Okay, so I'm going to quit this, and now I'm going to take X, and I'm going to store it as alpha B. So all I'll have to do is type in A and B in the calculator when I do this. Okay, so 166.575. You can write the rounded value, but when you do any calculations, you want to use the full decimal. Okay, all right. So now I'm going to go back to my paper. I'm going to record this. Okay, value. So this other time value was 166.575. Okay. All right, so now how do we get the amount of people waiting in the line, okay, for this, where is it a minimum, right? So what was it for A of 0? Okay, so A of 0, we automatically know that was 20 people because that was the amount of people waiting in line at time 0, okay? Then we want to find A of 330, or not 300, 33.013. 33.013. And we want to find what that is, okay? Now, that's going to be the 20 people, okay, plus the integral from 0 to 33.013. We can write it, but we wouldn't use that number, right? Of r of t, and then minus the integral from 0 to 33.013, 0.7 dt, okay? And that will give me the amount of people at time 33.013, okay? We're going to put that in our calculator and we're going to get an estimate. Now we're going to round to the nearest the nearest person, okay? Or the nearest whole number, okay? So we're going to go back to our calculator. I'm going to put this in, okay? Okay, so we're going to put in 20 and then plus, and then the integral from 0 to a, because a is the 33.013, okay, of y sub 1 and then dx, and then plus, no, sorry, not plus, minus, because we're removing, right? This is the number of people that are being removed from the escalator, which will change the length of the line, or number of people waiting in line. Okay, so minus another integral, and then number 4, and then 0 to a, and then 0.7, and then dx. Now I'm going to say something. You could do this as one integral. You could do the integral from 0 to a of y sub 1 minus 0.7, because there's a property of integrals that says you can bring these together, right? Okay, so you could do that and you'd have the right answer. Okay, you'd get the same answer as what I'm going to get the way I'm doing it. Okay, so we get 3.8. So that would be 4 people, okay, because we're rounding, all right, to the nearest whole number. So this would be 4 people. Okay, so now I want to do at this 166. So that'd be a of 166.575, and that would be 20 plus the integral. Let's go ahead and write this as one integral, okay? So 0, to show you what I was talking about earlier, 166.575 r of t minus 0.7, and I'd put parentheses around that, and then dt. That way we can just type it in as one integral. That would be a little bit faster, okay? Didn't realize it until I was putting it into the calculator that you could do that, all right? Okay, so let's go to the calculator and we'll do this one. Okay, so we're going to type 20 plus, and then we're going to do one integral, okay? Number 4, and then 0 to, this time b, so alpha b. And in the parentheses here, we type alpha trace 1 for y1, and then minus 0.7, and then dx. Okay, just a little bit faster putting in your calculator. Okay, and we get 158.07, so that's 158 people. So I'm going to go back and record that. Okay, so this would be 158, and then we need to find the other endpoint, right, at 300. So these were the critical points, and this was the endpoint, the left endpoint. We need to do the right endpoint, so that'd be a of 300, and that would be 20 plus the integral from 0 to 300 r of t, and then minus 0.7 dt, right? Okay. And we actually, didn't we already do that? We did that one, didn't we? Yeah, and what did we get? We got 80 people, right? So we already did this one. That's 80 people. Okay, so now it's a matter of just going through, okay, which one of these is the smallest? Okay, so when was the line the minimum? It was this one, right? There was only 4 people in line at 33.013 seconds, okay? All right, so let me slide this up, okay? So again, it was asking to the nearest whole number, find the number of people in line at this time, okay? So at t is about 33.013 seconds, the number of people in line was a minimum. The number of people in line was a minimum. At t is approximately 33.013 seconds, there were 4 people in line for the escalator. Let me slide that up a little bit. Okay, so and there's different ways. You have to include the time that it was a minimum, okay? And you also need to include at that time there was 4 people in line, okay? So you could say the number of people waiting in line was a minimum at t equals, well, I'm going to say the same thing I'm doing right here, okay? At t equals approximately 33.013 seconds, the number of people in line was a minimum. And then at that time, there were only 4 people in line for the escalator, okay? Hopefully you're starting to catch on to how these are asked, right? And you're getting better at, maybe this one you did better than like, you know, the very first one we did, okay? Because you notice I keep giving you these in and outs, right? This is like on every single exam, all right? And I'm sure it's going to be somewhere on this year's exam too, okay? All right. So I'm just getting you prepared for these. These are more difficult problems, and I'd be happy, really ecstatic for you, okay, if you got half the points on this. I mean, if you got 5 points on all of these free responses, you're on your way to getting like a 4 on the exam, okay? You're doing really, really good because these are really difficult questions, okay? And it's the type of questions I think they're going to ask you this year, okay? In my opinion. So hopefully I'm really preparing you. Hopefully you're taking the time to do all these problems and preparing yourself for this, okay? Because I know you guys can do it. I really have faith and I know you guys can do this because you guys are smart, okay? All right, so we're going to go on to 2017 number 4, which is the differential equations problem, okay? All right, so let's go ahead and go to that. So for the 2017 free response question number 4, this scenario deals with a potato that's being taken out of a for the 2017 AP Calculus AB free response number 4, this deals with a situation where you're taking a boiled potato from a pot that's in the kitchen and it's cooling, right? And they're giving you the initial temperature is 91 degrees Celsius. Now they actually tell you this a couple places. Okay, so here, the internal temperature of the potato is 91 degrees at time t equals 0, but they also say it right here. So there's 2 places they tell you that. The internal temperature of the potatoes is greater than 27 degrees Celsius for time t greater than 0. And they never give you extra information. We're going to use that information somewhere in this, okay? And then the internal temperature of the potato at time t minutes can be modeled by a function h that satisfies this differential equation. So h is the temperature in degrees Celsius and t is the time, right? And so this is the rate at which the potato is, in this case, it'd have to be cooling, right? Because it's taken out of the pot, okay? All right, so let's just jump in and answer question A. So question A is write an equation for the line tangent to the graph of h at t equals 0, and then use the equation to approximate the internal temperature of the potato at time t equals 3. So let's do the first one first. Let's write an equation for the line tangent to the graph of h at t equals 0. Okay, so I'm going to go to my paper and we'll work that one out. Okay, so to write the equation of the line tangent at t equals 0, we need the point at t equals 0, and we do have that, right? That's h of 0 is equal to 91. And then we also need to know the slope at 0, okay? So that'd be dh over dt at, okay? And it would be h is equal to 91. Now, why am I saying h is equal to 91 instead of t equals 0? Because our differential equation says it's negative 1/4 times h minus 27. So the rate at which it's decreasing, the temperature is decreasing, depends on the initial temperature, or the temperature that we're trying to find it at, okay? So this would be negative 1/4 times and 91 minus 27. Okay, so you're not going to be able to use a calculator on this part. And now I know on the AP exam, you're going to be able to use a calculator wherever you want, okay? But in this instance, they didn't want you to be able to use a calculator, okay? So that would be 64. So they actually give you nice numbers though, because this is negative 1/4 times 64, okay? And then that would be negative 16, okay? All right, so we can write our equation. It would be y is equal to my slope, which is negative 16, times t minus 0, or just t, and then plus 91. Okay, so this would be y is equal to negative 16 t plus 91. Okay, so that's the equation of the tangent line, right? Now, the only reason I went from here to here is because we were minusing 0, so you can just write it as t minus 0 is just t, okay? So let's go to the second part of this question, and they ask you, okay, use the equation to approximate the internal temperature of the potato at time t equals 3. So that would be, we're going to approximate h of 3, okay? So that would be h of 3 is approximately negative 16 times 3 plus 91. Okay, so that'd be negative 48 plus 91. Okay, and then negative 48 plus 91 is 43. Okay. At t equals 3, the internal temperature, I think internal, yeah, the internal temperature of the potato is 43 degrees Celsius. Okay, and that's the answer to question A. All right, so for part B, it says use the second derivative of h with respect to time for the second time to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. Okay, so we use this tangent line, right? But if the curve, if the actual function was concave up, then think about that bending up, okay, then that would mean our tangent line approximation is an underestimate, okay? But if our function was concave down, right, then it would be curving down, right? And then that would mean that our tangent line is an overestimate. So we got to determine the concavity of this, right? Okay, so first of all, let's just figure out, okay, what's the second derivative, okay? Let's do that first. And I'm going to go to my paper and we'll do that. So for part B, we know that the derivative dh over dt is equal to negative 1/4 times h minus 27. All right, so we need to take the derivative of this, right? Okay, so this would be negative 1/4 times the derivative of h minus 27 with respect to time, right? So that would be just dh dt, right? Because this is just 20, the derivative of 27 is just going to be 0. So negative 1/4 times dh over dt. You know what? Hold your horses. I just made a mistake and my notation's bad, okay? So let me erase this, okay? I just made a boo-boo, all right? Because what are we doing? I'm saying this is equal to the first derivative, right? We're taking the second derivative, okay? So the second derivative of h with respect to time for the second time is equal to negative 1/4 times, and the derivative of h with respect to time would be dh over dt minus, and then the derivative of 27 would be 0, okay? So now dh over dt is this negative 1/4 times h minus 27. So this is negative 1/4 times negative 1/4 times h minus 27, okay? So what's negative 1/4 times negative 1/4? That'd be positive 1/16, right? So that'd be 1/16 times h minus 27. Okay, so that's our second derivative, okay? So let's go back and let's read the question again. So we want to use the second derivative to determine whether part A is an underestimate or an overestimate of the internal temperature. So we got to determine the concavity of this, right? Now, a few things to think about, okay? If you look at this, I'm going to go back and forth between this and my derivative, okay, or my second derivative. Okay, so we can determine the concavity, but the concavity is determined on h, right? All right. Now, it depends on what h is, right? If h is bigger than this 27, this is always going to be positive, and then this is going to be positive because 1/16 is positive, right? But if h is under 27, okay, then we know that it's going to be negative, right? So what was it at 3, right? Okay, so let's go back, and what did they tell us at the very beginning? And this is where you need this piece, okay? The internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. So for greater than 0, for all the times, h is above 27 degrees Celsius, okay? So back here we could say h is greater than 27 degrees Celsius for t greater than 0, okay? What does that mean? That means this is always going to be positive, right? So on this interval, h of t is concave up because the second derivative is positive, okay? So h of t, and it's going to be concave up for all t values, okay? So h of t is concave up for all t greater than 0 because the second derivative of h with respect to time for the second time is greater than 0 for t greater than 0. So it's concave up. So we have a function that's concave up, and we have a tangent line, right? So this is the actual function. This is our estimate, right? We're off because we found this at 0, right? So right here would be like if this is t equals 0, t equals 3 would be somewhere like right in here, right? And there's a gap between the two. But since we know it's between what the actual value is, which would be right here, and the estimate that we did with the tangent line, right? So because it's concave up, I know the actual is more, right? So that would mean our estimate in part A is an underestimate, okay? So therefore, and this, we've seen this a few times now, right? So therefore, the estimate in part A is an underestimate. Okay? And that's all we have to do is for part B. All right? All right, so let me go back to our question and we'll look at part C. Okay, so for part C, for t less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g, satisfying this differential equation, right? And then where g of t is measured in degrees Celsius and g of 0 is equal to 91, find an expression for g of t based on this model was the internal temperature of the potato at time t equals 3, okay? So this is a differential equation, right? And we need to figure out what g of t is. So this is a separation, this is gonna be a separation of variables, okay? All right, so let's go ahead and do that. I'm gonna grab my paper and we'll work that one. Okay, so what we know for part C is that dg over dt is equal to this, and we also know g of 0 is equal to 91, all right? So what we wanna get is our g, which is g minus 27 to the 2/3. I need to get that over to the left-hand side. And so this is gonna become -1 and then dt, okay? So this is gonna be 1 over g minus 27 to the 2/3 power is equal to -1 dt. And I forgot dg right here. Okay. So then we're going to integrate both sides. Okay. And then this one, I'm going to rewrite as g minus 27 to the -2/3. And then dg is equal to the integral of -1 dt. Okay. Now, if I let u, I'm going to do u, I'm going to let u equal g minus 27, then du would simply be dg, right? dg. Okay. And so then this is u to the -2/3. You wouldn't have to do a u substitution on this. Okay. You could just do it mentally. All right. So this is u to the -2/3, and then du is equal to the integral from -1, or not from, the integral of -1 dt. So we're going to add 1 to this and divide by that new power, right? So we're going to add 3/3 to this. That would make u to the 1/3 divided by 1/3, but a better way is to multiply by 3. Okay. And then that's equal to -1 t, or -t plus c. Okay. Now this u gets switched back, right, to g minus 27. So this is 3 times g minus 27 to the 1/3 power is equal to -t plus c. Okay. Now for this problem, what I would do, I think I would find the c right now. Okay. So you have two options: get g by itself and then plug the 0.91 in, or the other option is to go ahead and plug it in right now and figure out what c is. That's what I'm going to do. I just think it's going to be a little bit easier. Okay. So this is going to be 91 minus, right, 3 times 91 minus 27 raised to the 1/3 is equal to, because this is going to be 0, right? So that's just c. Okay. So 91 minus 27, that would be 64. So this would be 3 times 64 to the 1/3 power is equal to c. Okay. And then, okay, so what could you cube to get 64? Well, it'd be 4, right? So this is just 3 times 4, which is equal to c, which means 12 is equal to c. Okay. So now back here, this is our actual equation, but now we know the c value right here, right? That is 12. So really what we have is 3 times g minus 27 raised to the 1/3 is equal to -t plus 12. Okay. Now we want to get g by itself. Okay. So the very first thing we'd want to do is to get rid of this 3. Okay. So this is going to be g, and 1/3 power means cube root, right? So then g minus 27 raised to the 1/3 power is equal to, you could write this as -t plus 12, or 12 minus t over 3. I'm going to write it as 12 minus t over 3. Okay. And then we're going to want to cube both sides because I want to get rid of the 1/3 power. So I'm going to raise both sides to the 3rd power. So that would give me g minus 27 is equal to, okay, and this right-hand side would be 12 minus t over 3 to the 3rd power, and then adding 27. So g is equal to 12 minus t over 3 cubed plus 27. Okay. And there's only one function for this. That's it. Okay. All right. So, okay. So g of t would be the function 12 minus t over 3 cubed plus 27. Now, there's other ways you could solve this, okay? There's other ways you could get G by itself. And so I want to make that really clear. This is not the only, this is one version of the answer, okay? So if you cube the top and you cube the bottom and got a common denominator and did stuff like that, that'd be fine. But you don't have to, okay? If you get an answer that's a correct answer, that's all that matters, okay? And you show your work that leads to that answer, okay? All right, so then we need to also, because there was another part to this, right? So I'm going to grab my problem back, okay? Find an expression for G of T. We did that, right? Okay, and based on this model, what is the internal temperature of the potato at time t equals 3? Okay, so what was the temperature of this potato? Okay, so we got to find that. So what is G of 3 for our function? What's G of 3? And G of 3 would be 12 minus 3 over 3 cubed plus 27. Well, 12 minus 3 is 9. And then 9 divided by 3 is 3. And then 3 cubed is 27. So G of 3 is equal to 27 plus 27, right? So 27 plus, well, 20 and 20 makes 40, right? And 7 and 7 make 14. So this is 54. So G of 3 is equal to 54. Now that's 54 degrees Celsius, right? Okay, so this estimate is saying that the temperature would have been 54 degrees Celsius, okay? And you can't see that. Sorry, guys, let me take this off. I'm busy talking and I don't look at the screen to see where it's at. Sorry. Gosh darn, mad at myself right now, okay? So what I was saying is G of 3 is 12 minus 3, which is 9, divided by 3, which is 3, cubed is 27. So I have 27 plus 27, and then that would be 54. Okay, so this is 54 degrees Celsius. Okay, that's what this one predicts. Okay, so I would write a little statement here. The internal temperature of the potato is 54 degrees Celsius at t equals 3 minutes. Because remember, t was measured in minutes. Okay. All right, guys. All right. Hopefully, you're like this is starting to catch on, and you are really you're starting to get better. Because do you notice that these problems look very similar to other problems that we've done over the last the free responses we've done over the last couple days that we've done the free responses. Okay. So hang in there, guys. Hey, if there's anything that you need, just let me know. If you're having struggles with something, if you're having problems, if you're having technology problems or anything, reach out to me, get a hold of me, okay? If you, I will do a one-on-one tutoring session with you. If it's 9 o'clock at night and that's the only time you can do it, I'll do it at 9 o'clock, okay? Probably won't do it 2 in the morning, all right? Because I know a lot of you guys are up at 2 in the morning, but I like to sleep, okay? But I'm happy to help you guys. You just got to let me know, like, Mr. Mitchell, I need help. I don't understand what's going on here. I can pull up my document camera and we can do a live session where I'm discussing things, okay, with you. And I have no problem doing that, okay? Because this is about you right now and getting you ready for the AP exam, okay? So you guys can do this, all right? If you take the time and put the effort in, you're gonna do okay on this exam, guys, okay? You're gonna do just fine, all right? So hang in there. And I'll see you tomorrow, okay? Take care, guys. Have a great day. Bye.